am Mary Swarnalatha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on correlation function and its properties. So already in the previous lecture, we have seen about the correlation of a random process. In that, we have seen autocorrelation and cross correlation. So what is a correlation? Correlation nothing but measuring the similarity between two quantities is called as what? Correlation. Now what is autocorrelation? So autocorrelation nothing but you have to take a single random process x of t, and this random process will define two random variables by keeping the time constants at t equals to t1 and t equals to t2. And the correlation or the measuring the similarity between these two random variables which are defined on this random process x of t is called as autocorrelation. Now what is cross correlation? Cross correlation nothing but you have to consider two different random process x of t and y of t. On the random process x of t, we are defining a random variable by keeping the time as constant, let us say at t equals to t1, and you are defining one more random variable on the random process on another random process y of t by keeping the time at t equals to t2. Now, measuring the similarity between these two random variables which are defined on two different random processes is called as cross correlation. And the autocorrelation has been represented by Rx's of t1 comma t2, whereas the cross correlation between two random processes x of t and y of t have been represented by Rxy of t1 comma t2. Now, so the problem is here, given a random process x of t equals to a into e power minus at, where a is a constant and capital A is a uniform random variable which is ranging from 0 to 1. So the question here, they have given the random process x of t. What is a random process? A random process is a function of the random variable and time. So here in this random process, a is a random variable and t is a time. So the combination of these two nothing but what? The random process. So they have defined the random process. In that random process, they are given capital A is a uniform random variable which has been distributed over the interval 0, 1. And you have to calculate the mean and autocorrelation of the random process x of t. Now, so what they have given? They have given the random process x of t is equals to a into e power minus at. So in this random process, capital A is a uniform random variable which is distributed over the interval 0, 1. Now, if x is a uniform random variable, what is density function? Fx of x equals to 1 by b minus a when x is from a to b. Now, in place of a have 0, in place of b have 1. Then, what is the density function of this uniform random variable? A is equals to fa of a is equals to 1 by b minus a, nothing but 1 by 1 minus 0, that is nothing but what? 1. For what values of a? When a is from 0 to 1. So, when a is from 0 to 1 and 0 otherwise. If you plot the density function of that uniform random variable, so on the x-axis I am taking a and the y-axis I am drawing the density function of the random variable, uniform random variable a. So, where it is defined? It is defined from 0 to 1. From 0 to 1, what is the density function value is equals to 1. So, when it is from 0 to 1, it is 1. And for other values of a, it is 0. So, why it is? That's why since from 0 to 1, the density function is uniform, it is a constant over this interval. This random variable is called as what? Uniform random variable. Now, what you have to calculate? You have to calculate what? First, mean of the random process x of t. Now, the first problem is, we have to calculate the mean of the random process x of t. That is nothing but expectation of x of t. That equals to expectation of what is the random process x of t in the given problem. They are given a into e power minus at. So here a into e power minus at. Now what is expectation? Expectation nothing but what is called as what? Statistical average. Here what is expectation? Nothing but here represents what? The statistical average. Nothing but what? Expectation. This is also called as what? Mean. This is also called as what? Average. Simply called as, instead of saying statistical average, simply called as what? Average. So always the statistical average will be calculated with respect to the random variable. So here which is the random variable in the given random process? A is a random variable. So remaining terms bring it outside. Then how we can write this as e power minus at into expectation of A. Now what is expectation of X formula? We know that expectation of X, if X is a continuous random variable, what is the formula? Integration minus infinity X into fx of X into dx. This is a what? Formula for a continuous, the expectation of a continuous random variable X. Now in place of X, now we have the random variable A. Then you can write this as e power minus at into integration. And what type of random variable here? A is info random variable, which is of what? A continuous random variable. Therefore, we can write the expectation as what? Expectation of A as A into f A of A into d A. Now, what is f A of A? That is nothing but what? The density function of the info random variable. What is it? Value equals to 1. For what values of A? When A is from 0 to 1. Therefore, when A is from, this is nothing but e power minus at into integration 0 to 1 A into, in this interval, what is the density function value equals to 1. So, into what? dA equals to e power minus at into, what is the integration of A with respect to A? You will get as what? A square by 2. And what is the range of A? Is from 0 to 1. So, therefore, e power minus at into, and substitute the upper and lower limits. And what can you obtain here? 1 square minus 0 square by 2. There is nothing but what? 1 by 2. So, e power minus at by 2. Therefore, this is what? The mean of the random process x of t. Next, what you have to calculate? You have to calculate the autocorrelation function of the given random process. So, therefore, you can write as what? What is the autocorrelation function of a random process x of t? Rx of t1 comma t2 is equals to what? Expectation of x of t1 into x of t2. Let us say if t1 is equals to t and t2 is equals to t plus tau. Then what is the autocorrelation function? Write as what? Rx of t comma t plus tau is equals to expectation of x of t into x of t plus tau. So that equals to expectation of what is x of t? A into e power minus at. And what is x of t plus tau? Is just replace t by t plus tau here. Then you can write x of t plus tau as a into e power minus a into t plus tau. That equals to expectation of a square into e power minus at into e power minus a into t plus tau. Now, what is the statistical average? You have to calculate with respect to random variable. In this, which is a random variable? A is a random variable. Therefore, keep this term inside and remaining terms bring it outside. Then you can write this as what? E power minus at into e power minus a into t plus tau into expectation of a square. So that equals to, you can simplify as what? E power minus, so you can write this e power minus at into e power minus at plus tau as what? E power minus 2at minus a tau. And what is the expectation of a square? Integration minus 0 to 1 you can write directly. So a square into, what is f of a here? 1. So dA. That equals to e power minus 2at. So minus a tau, integration of a square is nothing but a cube by 3 and the limits are from 0 to 1. Then if you simplify this after substituting the upper and lower limits, you can write this as what? E power minus 2at minus a tau by 3. So like that you can calculate for the given random process the mean and autocorrelation function. And second problem here is find the mean autocorrelation function variance and autocovariance of the random process x of t equals to t into u, where u is a uniform random variable which is distributed between the interval 0, 2. So what they have given is a similar problem only. So they have given the random process x of t equals to what? T into u. So what is the random process? A function of what? The time and the random variable. In this, which is a time, t is a time and u is a uniform random variable. So what is u here? It is a uniform random variable which is distributed over the interval 0, 2. Now, what is the density function of the uniform random variable? Fu of u equals to 1 by 2 minus 0. Nothing but what? 1 by 2. For what values of u? When u is from 0 to 2 and 0 otherwise. Now, what you have to calculate first? The mean of the random process. So, how do you calculate the mean of the random process x of t? So, there is nothing but what? Expectation of x of t. So, that equals to expectation of what is x of t here? They have given t into u. So, that equals to here, which is a random variable, u is a random variable. Always expectation we calculate with respect to the random variable. So, bring this t to the outside, then t into expectation of u and equals to t into, and what is the range of the density function of here? 0 to 2. In this density function, what is the value here? 1 by 2. So, integration 0 to 2 u into 1 by 2 into du. That equals to what? T into, so t by 2 into, so integration of u is nothing but u square by 2 and the limits are from 0 to 2. So, that equals to t by 2 into 2 square minus 0 square by 2, that equals to, here we will get 4t by 4, that equals to what here? T. So, this is what the mean of a random process x of t. And second one, what you have to calculate? You have to calculate the autocorrelation function. So, you have to calculate what? The autocorrelation of the random process x of t. So, what is the autocorrelation function? Previously, I have defined Rx of t comma t plus tau is equals to expectation of x of t into x of t plus tau, that equals to expectation of what is x of t here? T into u. Then what is x of t plus tau? In place of t, replaced by t plus tau. Then you can write t plus tau into u. That equals to the expectation with respect to random variable. Therefore, bring this t into t plus tau outside. Then you can write this as what? T into t plus tau into expectation of u square. That equals to t into t plus tau. The expectation of u square nothing but what is the density function here? From 0 to 2. So, u square into what is the value here? 1 by 2 into what? Du. That equals to what? T into t plus tau into, and what is the integration of u square? So, bring this 1 by 2 outside. So, integration of u square nothing but u cube by 3 and the limits are from 0 to 2. Then what can I apply here? So, t into t plus tau by 2 into u cube by 3. So, what is upper limit? 2. So, 2 cube minus 0 cube by 3. So, that equals to here t into t plus tau into 4 by 3. This is nothing but what? The autocorrelation function of the given random process. And third one, what you have to calculate? You have to calculate what? Variance. After that, you have to calculate the autocovariance. So, we will calculate the variance. So, what is the variance of a random process x of t? That is nothing but what? Sigma square is equals to expectation of x square of t minus u of x of t whole square. This is nothing but the mean of a random process. It's already calculated. Now, if you calculate u of x square of t, then you can calculate the variance of the random process. So, first you will calculate the mean square of the random process. Now, what is e of x square of t? That equals to what? Expectation of what is t here? X of t, t into u. So, whole square. That equals to what? Expectation of t square into u square. And bring that t square outside because only u is the random variable here. So, expectation of u square, that equals to what? So t square into, what is the expectation of u square? So nothing but 0 to 2 u square into, in this interval what is the density function? 1 by 2 du. So equals to what? T square by 2 into u cube by 3, and the limits are from 0 to 2. That equals to what? T square by 2 into 2 cube minus 0 cube by 3. That equals to, you can obtain this as what? 4t square by 3. This is nothing but what? The mean square of the random process. Now, substitute the mean square of the random process. And what is the mean of the random process? We got t. So then you can write down the variance as what? Sigma x square equals to e of x square of t minus e of x of t whole square. So what is here? E of x square of t. So 4t square by 3 minus, what is the mean of the random process? Got t. So t square. So if you bring t square common, then you can write 4 by 3 minus 1, that equals to what? T square by 3. This is what? The variance of the random process. And what is the fourth one you have to calculate? Auto covariance of the random process x of t. Nothing but cxs of tau. So what is cx of t comma t plus tau is equals to? Cx of t comma t plus tau equals to, you can write this as what? Rx of t comma t plus tau minus expectation of x of t into expectation of x of t plus tau. So already you have calculated the autocorrelation function. You have calculated the mean of the random process of t. Now you will calculate u of x of t plus tau. So what is u of x of t plus tau is equals to, so in the expectation of, what is x of t plus tau? So t plus tau into u. That equals to what? T plus tau into expectation of u. So what is the expectation of u? Already you have calculated. That value is equals to here. Expectation of u is nothing but here for t. So in place of t here you will get t plus tau. So directly can write down t plus tau. So therefore the auto covariance cxs of t comma t plus tau is equals to, what is the auto correlation we got here? T into t plus tau 4 by 3. So here t into t plus tau into 4 by 3 minus e of x of t. What is e of x of t? T. And what is e of x of t plus tau? T plus tau. So if you take t into t plus tau common, you get 4 by 3 minus 1. That equals to what? T into t plus tau by 3. So like that you can calculate for the given random process the mean, autocorrelation, variance and autocovariance. And the next problem here is statistically independent zero mean random process x of t and y of t have autocorrelation functions. Rxs of tau is equals to e power minus mod tau and ryy of tau is equals to cos of 2 pi t respectively. So what is the first problem here? Find the autocorrelation of the sum w1 of t is equals to x of t plus y of t. It means you have to add those two random process and then you have to calculate the autocorrelation of the sum of those two random process. And second one is the autocorrelation function of the difference of those two random process. And the third problem is cross correlation function of the sum of the random process and the difference between those two random process. So therefore, so what they are given? First they have given what? X of t and y of t are statistically independent. They have given first point. Second point they have given they are having zero mean. And third point they have given the autocorrelation functions are e power minus mod tau and for the random process y of t it is cos of 2 pi into t. So they have given 3. So what is zero mean? Nothing but what? E of x of t is equals to E of y of t value equals to 0 because they are given that the two random process having zero mean. So what do you mean by statistically independent? So statistically independent. So if they are statistically independent, then what is e of x of t into y of t plus tau is equals to nothing but e of x of t into e of y of t plus tau. This is called as what? Cross correlation function. So therefore, what is Rxy of t comma t plus tau is equals to expectation of x of t into y of t plus tau, that equals to what? Since they are independent, they have given that independent, these two are. You can write this as what? U of x of t into u of y of t plus tau. But they have given that random process 0 mean, therefore it equals to 0. Therefore, what is Rxy of t comma t plus tau is equals to 0. Now, what is the first problem they have given that? You have to calculate the autocorrelation function of the addition of those two random process, the sum of those two random process x of t and y of t. Now, what is the autocorrelation function of the random process? W1 of t nothing but W1 of t comma t plus tau is equals to what? Expectation of W1 of t into W1 of t plus tau. So that equals to, this is the first problem, that equals to what? Expectation of what is W1 of t? X of t plus y of t. So therefore here x of t plus y of t, and what is W1 of t plus tau? X of t plus tau plus y of t plus tau. So here x of t plus tau plus y of t plus tau. So that equals to what here? Expectation of x of t into x of t plus tau, then x of t into y of t plus tau plus y of t into x of t plus tau. Just multiply those two product components. Then you'll get plus y of t into y of t plus tau. So that equals to what? Expectation of, you can write this as what? U of x plus I was u of x plus u of y plus u of z, like that. Therefore, you can write this as what? Expectation of x of t into x of t plus tau plus expectation of x of t into y of t plus tau plus expectation of, here you can write down, plus expectation of y of t into x of t plus tau. So y of t into x of t plus tau plus expectation of y of t into y of t plus tau. So y of t into y of t plus tau. So that equals to what is expectation of x of t into x of t plus tau, which is called as what? The autocorrelation function of random process x of t. Therefore, we can write this as what? Rxs of t comma t plus tau plus what is the expectation of x of t into y of t plus tau? So since this is two of the different random process, this is called as what? Cross correlation function Rxy of t comma t plus tau plus what is expectation of y of t into x of t plus tau? Yx of t comma t plus tau plus the expectation of y of t into y of t plus tau, nothing but what? Ryy of t comma t plus tau. Now what is Rx of t comma t plus tau given? E power minus mod tau. And what is Ry of tau equals to cos 2 pi tau. This is not t, this is cos 2 pi tau. So they have given the autocorrelation function of the two random process. So given, so what is autocorrelation function of the random process of t? E power minus mod tau. And what is autocorrelation function of the random process y of t? Cos of 2 pi tau. Now, since the two random processes are statistically independent, Rxy of t comma t plus tau equals 0, and similarly, you can write down Ryx of t comma t plus tau is equals to 0. Therefore, here Rxy of t comma t plus tau equals 0 and ryx of t comma t plus tau equals 0. So therefore, the autocorrelation function of the random process w1 of t is equals to rw1 of t plus tau is equals to rx of tau. What is rx of tau? E power minus tau plus rxy of tau is 0 plus ryx of tau is 0 and ry of tau is cos of 2 pi into tau. Therefore, you can obtain here e power minus mod tau plus cos of 2 pi tau. What does it mean from this? What can you say that if two statistically independent random process with 0 mean, you have two random process of certain way of they are statistically independent, they have 0 mean. Then the autocorrelation function of sum of those two random process is equal to the sum of the autocorrelation function of the individual random process. So that statement you can give. And second one, what you have to calculate? The autocorrelation function of the difference of the two random process. So nothing but W2 of t plus tau is equals to. So what is W2 of t equals to? We have given x of t minus y of t. Then what is our autocorrelation function? E of W2 of t into W2 of t plus tau. And equals to what? Expectation of what is W2 of t? X of t minus y of t into what is W2 of t plus tau? Just replace t by t plus tau here. You will get here x of t plus tau minus, you will get y of t plus tau. So here y of t plus tau. Now you can write this as what? X of t into x of t plus tau. So x of t into x of t plus tau minus y of t into x of t plus tau. X of t plus tau. So x of t into minus y of t plus tau. So x of t into y of t plus tau. So minus of minus will get here plus. So y of t into y of t plus tau. So y of t into y of t plus tau. That equals to what? Expectation of x of t into x of t plus tau minus expectation of y of t into x of t plus tau minus expectation of x of t into y of t plus tau. So plus expectation of what here? Y of t into y of t plus tau. That equals to, so what is expectation of x of t into x of t plus tau is equals to here rxs of t comma t plus tau minus this is what? R yx of t comma t plus tau plus here this is rxy. So rxy of t comma t plus tau plus this is nothing but ryy of t comma t plus tau. Then what they are given here, x of t plus tau is what? E power minus mod tau. Then minus 0 plus 0 plus ryy of tau is equals to what here? Cos of 2 pi into tau. That equals to what? E power minus mod tau plus cos of 2 pi tau. So this is nothing but what? The autocorrelation function of difference of the two random process. It means if x of t and y of t are statistically independent with 0 mean, then the autocorrelation function of sum of these two random process and the autocorrelation of the difference of these two random process is equal to what? Sum of the autocorrelation function of individual random process. And what is the third bit here? You have to calculate the cross correlation function of W1 of t and W2 of t. It means you have to calculate W1 of W2 of t comma t plus tau is equals to what? Expectation of W1 of t into W2 of t plus tau. That equals to expectation. What is w1 of t here? X of t plus y of t. And what is w2 of t plus tau? X of t plus tau minus y of t plus tau. That equals to what can happen here? Expectation of x of t into x of t plus tau minus x of t into y of t plus tau plus y of t into x of t plus tau minus y of t into y of t plus tau. And equals to what is this? The autocorrelation function rx of t comma t plus tau. This is nothing but cross correlation function rxy of t comma t plus tau. This is nothing but autocorrelation function ryy of t comma t plus. This is nothing but cross correlation function ryx of t comma t plus tau, and then minus r. This is the autocorrelation function. So ryy of t comma t plus tau. And what is the cross correlation function? This to random process equals to 0. Therefore, what can happen here? E power minus mod tau minus cos of 2 pi tau. So from this, what can you say that if you have two random process x of t and y of t with the statistical independent having 0 mean, then the cross correlation function of the sum of the two random process and the difference of the two random process is equal to the difference of the autocorrelation function of the individual random process. And what is the next question here? Compute the variance of the random process x of t whose autocorrelation function is given by rxs of tau is equals to 16 plus 2 by 1 plus tau square. So what they have given here? They have given the autocorrelation function only. What is what value they have given? 16 plus 2 by 1 plus 2 tau square. So what you have to calculate? You have to calculate variance of the random process. They have not defined the random process, but they have given only the autocorrelation function. It means how can you calculate the variance? You have to use the properties of the autocorrelation function and then you have to calculate the variance of the random process. So from properties of autocorrelation function, so what is the mean of the random process? What is that? So rxs of mod tau. So limit mod tau tends to infinity. Rx of tau is nothing but what? E of x of t whole square. So this is what from the properties of autocorrelation function write down. Now substitute here tau equals infinity. Then what can you obtain here? You can obtain 16 plus 2 by 1 plus 2 in infinity. Nothing but what? 16 plus 2 by 1 plus 0. So 1 by here 1, 2 by infinity. So it is 2 by infinity value 0. Nothing but here 16. So from this e of x square of t. So e of x of t whole square is equals to 16. From this, what is the mean of the random process? E of x of t equals to 4 plus or minus 4. And then for the variance, what you have to calculate? You have to calculate mean square value also. So again, from the properties of autocorrelation function, we can write down e of x square of t, nothing but what? The mean square of the random process is equal to rxs of 0 only. Therefore, what is e of x square of t here? That equals to rx of 0. So what is rx of 0? In this given autocorrelation function, substitute tau equals 0. Then you can obtain 16 plus 1 by 16 plus 2 by 16 plus 2 by 1 plus 0. It equals to what? 18. And what is the variance of the random process here? Sigma x square is equals to what? Expectation of x square of t minus expectation of x of t whole square. And equals to what is the mean square of the random process from this? 18 minus what is the mean of the random process we got? Plus or minus 4. Therefore, look at here 18 minus 16 is equals to 2. Therefore, what is our variance of the random process we got? 2. So like that, if they give the autocorrelation function, so from the properties of the autocorrelation function. You can calculate the mean, variance, autocovariance, autocorrelation, like that. So like that, you can solve the problems by using the properties of the autocorrelation function as well as the cross correlation function. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.